Well, good evening and welcome to Environmental Coffee House. It's me, Sandy Schoelles, trying to fix something here and get going. And hi, Jennifer. Welcome.
Hi.
Welcome.
Good to
Oh
see
my
you, Sandy.
gosh. Oh, as
Good to
always,
see
it's good to
everybody.
see you. Yeah, it is. We have a lot of people in the audience, and I'm sure that more will
Woo.
be joining. Thank you, everybody, for coming. We have a good show tonight. Of course, as usual, Jen will give the spaceship overview of everything we're going to do, and we have a little intermission video I've made tonight for as we go along, a little video treat. So what's happening, Jen?
Well, we got a great show lined up for everybody today. We've got a couple of articles about animals. So the first articles from Smithsonian Magazine. Beavers are reshaping the Arctic tundra. Here's why scientists are concerned. We talked about this actually last week, but this is a deeper dive into it.
Yes.
Ponds made by the large rodents are causing permafrost to thaw, releasing methane and carbon dioxide once stored in the frozen earth. So that's number one. Number two is an article about the reindeer from the Barron's Observer, dearly
One of our
loved
favorites,
periodical.
yes.
It is, it is. And
Mm-hmm.
Tomas took one of the reindeer pictures. I don't know if you noticed that, Sandy. Um, Thousands of reindeer gone astray in Lapland. The ice cover under the snow caused by climate changes creates severe challenges for reindeer in northern Finland this winter.
Stuff.
I know, so sad. And then we're going to talk again a little bit about the Arctic report card that we talked about last week, but in a slightly different way.
Mm-hmm.
Grim Arctic report card not good for Southwest Florida environment, you know?
Interesting.
Just showing how the Arctic affects everything, right?
Everywhere.
So, yeah, it
Yeah.
really does. Then we have an article from the United Nations News. Climate change for the 25th year in a row, Greenland ice sheet shrinks. And then we've got a short article from the New Scientist about methane. Record levels of greenhouse gas methane are a fire alarm moment.
Oh boy.
Average atmospheric concentrations of methane reach 1900 parts per billion globally, not
Yeah.
just in the Arctic,
So we'll
which is
talk about
different
that.
from what we were talking about last week.
Mm-hmm.
Last September, the highest in nearly 4 decades of records. Oh, you
Oh
betcha,
God.
baby. You betcha, baby.
Mm-hmm.
Sad.
Mm-hmm.
Then we have one from The Guardian. Drastic rise in high Arctic lightning has scientists worried. This is an interesting one. The region's air typically doesn't suit strikes, so they have become an important climate crisis indicator. Wow. And what
Wow.
else is up in the Arctic, Sandy? Permafrost drying out, right?
Yes.
More lightning,
More
more dry
lightning,
permafrost.
more problems.
It can't end well.
No.
Then we may or
If we
may
have time.
not, if we have time, we
Yeah.
have an article from Severe Weather Europe, Weather 2022. New anomalies are growing in the atmosphere and the oceans that will change the weather patterns as we head deeper into the year. And I hope, Sandy, we will put these links in the show notes, even if
Absolutely will.
yeah. And
Yes,
the
I.
other one we'll do a kind of an either or, if we
Mm-hmm.
have time, is the newest one from Counterpunch from Robert Hunsinger, When to Build Seawalls. So we'll see if we get to those, but we'll definitely get to those other articles that we talked about. So,
Okay.
Sandy, we've got an action packed show.
Yeah, we do. We do.
Yeah.
Okay. All right. So let's get started on the first one. I will pull it up and get us ready to roll. This one is the article from the Smithsonian, and let's pull ourselves up together as well.
Hmm.
All right, so here we are. Jennifer, I'll start this one out if you don't mind.
Hmm. Hmm.
So the
Go
the
for it.
ponds, the beavers, the ponds made. I think you had said this, causing the permafrost to thaw, and it is releasing the methane and that carbon dioxide once stored in the earth, in the frozen
That's
earth.
right.
And look at this little thing here.
Oh,
I think we
they're
should leave them
cute.
alone, but let's yeah, but nobody can ever
Cute.
leave anything alone. So beavers, they have the ability to completely transform landscapes. They gnaw through trees, they build dams, they flood new areas to create ponds, earning them the title of ecosystem engineers. But a northward migration of these buck-toothed builders has scientists concerned, Hannah Osborne reports for Newsweek. Now, that's interesting that Newsweek that
Hmm.
Smithsonian is using a Newsweek
I
reporter.
know. It's a
But
strange alliance.
yeah, a new report about beavers is a part of the NOAA annual Arctic report card again, but comparing decades old aerial images of a region in western Alaska with newer ones, the researchers have found that the number of ponds created by the beavers has doubled in the last 20 years. They found more than 12,000 ponds. Wow. In the same
Wow.
area in 1955, there wasn't a single one. Oh my gosh. That's
No
insane.
kidding.
This is what we're going to be seeing, this kind of
Hmm.
migration. We didn't know what we would find and ended up being very surprised, Ken Tape, an oh boy, I have to correct, ecologist at the University of Alaska, Fairbanks, tell Oliver Millman for The Guardian. There are areas of Alaska that had no evidence of beavers 50 years ago that are now apparently saturated with them, he says. It's just a matter of time before they head even farther north. When you consider this is likely happening across the rest of the Arctic, in Canada and Russia, that gives you an idea of the scope of this change. So
Mm.
beavers, they can create shallow pools of water when they build their little dams. That has increased the total surface water in the region, raising concerns since these ponds are warmer than the surrounding ice, causing that permafrost, the permanently permamush, frozen ground to thaw out. Permafrost is a critical carbon sink, and its thawing releases carbon dioxide and methane that has been stored for years. Newsweek reports. Newsweek must have more money than the Smithsonian to report on this stuff. Researchers saw a dramatic increase in surface water across that region, and they attributed around 66% of this increase to the beaver's presence, CBS reports. So those ponds absorb heat better. They change the hydrology of the area, and the permafrost responds to that, Tape tells The Guardian. It's accelerating the effects of climate change. When you realize what's happened in Western Alaska is likely to happen to Northern Alaska, it does give you pause. There's also an added concern about how the reshaped landscape and waterways will affect indigenous communities in Alaska. Beaver dams could affect aquatic food webs and fish populations, as well as make boat access way more difficult. More research is currently underway to parse through how the beavers will affect the ecosystems and indigenous livelihoods, says Helen Wheeler, an ecologist at Anglia Ruskin University in England. So they're actually drawing from a wide variety of researchers. It's still unclear why the beavers are expanding northwards in the first place. That's going to be something for us to watch. It could be the effects of warming climate, such as the abundant vegetation, has made that region more habitable to beavers, The Guardian reports. It could also be a booming population of beavers expanding northwards to predator-free zones, or a combination of the two. So it is not entirely clear, but we do know that beavers are having a significant, impact on the ecosystems they are colonizing, and that is pretty wild. And last week when we talked about this, a lot of people were of the opinion, leave them alone,
Hmm.
leave them alone. I don't know what how you feel about it. I don't know enough I really don't know enough. I don't want to
Well,
see anything changed.
I don't think we should hurt anything at this point. They're all
No.
gonna die sooner than
Oh
expected.
my gosh.
Um, that being said, the beaver dams are causing these huge floods in the frozen permafrost areas, and it's
Mm,
causing all this water to run into all these places in the permafrost and warm it up and thaw it up. So, the effects of the beavers is going to be more methane and more greenhouse gases, carbon dioxide, the whole thing, because that's going to accelerate the process. It's just going to happen that much faster, Sandy.
oh, Jennifer. Jennifer, Jennifer.
I know.
Well, why don't you take it away with the reindeer, which
Sure.
I loved,
Okay.
of course. I mean,
I know.
I love the reindeer. I don't love what's happening.
No, no, of
And
course
that's a
not.
beautiful picture.
Well, this is an article that just came out in the Barents Observer, and we did have the editor of the Barents Observer on here, Tomas, and I can't remember his last
Thomas
name.
Nielsen, and we should have him back.
Tomas Nielsen.
Hmm.
Yeah, oh, he was great. It was such an interesting interview
Yeah.
with him.
If you
Yeah.
haven't seen it, it's in our show notes. I mean, it's in the playlists in under interviews.
Oh, okay.
Yeah.
All right, well, let's take it away. Thousands of reindeer gone astray in Lapland. Ice cover under snow caused by climate changes create severe challenges for reindeer in
I
northern
love the picture.
Finland
Mm.
this winter. And this just came out. Whereas further south, the reindeer can munch on easily accessible lichen under the snow. North in Lapland, lichen consumption comes with a lot more difficulties to the animals. Some
Mm.
of the stray reindeer went over 100 kilometers south of their supposed locations to find adequate quantities of nutrition.
Mm.
According to the herders speaking to the BBC, thousands of reindeer have gone missing north in Finland this winter. A layer of impenetrable ice solidifying atop their food source made it impossible for the animals to access the lichen, which is a key staple in the reindeer's diet during the winter months. Climate change is the cause for this unexpected icy phenomenon. If rain and warmer temperatures, which produce slush like snowmelt, are rapidly followed by colder sub zero temperatures, a hard layer of ice covering the soil forms. Finnish broadcaster YLE explains.
Hmm.
According to Juko Kumpula, an experienced scientist at Finland's Natural Resources Institute, quote, reindeers cannot dig through the ice as it is hard, so they move away in search of ground where there is just snow that they can
Hmm.
remove easily and eat the lichen below. So the poor things are starving. It's so
Oh my
sad.
gosh. Yeah.
This explains the recent migration and sudden disappearance of thousands of reindeer, Kampula said to the BBC. Lapland is renowned for its reindeer herding, which is also the way of many Sami indigenous people in the region make a living. Currently, Lapland herders are working around the clock to bring back their herds and business. However, returning the animal
Hmm.
flocks back to the north is both a complex and costly process. The different reindeer herds have intermingled on their way southwards. Therefore, locating one's own animals from those of the other herders is quite complex. Although the reindeer are typically equipped with GPS trackers, these do not always work. And even if they do, the devices sometimes get separated from the rest of the herd. In these situations, the herders must sift through groups of thousands of reindeer one by one.
Oh my gosh.
And this is that picture that Tomas took of all the reindeer in the snow.
All right, wait.
Anna Karen's seven
Oh. Look at
Benson.
that.
Isn't it wonderful?
Hmm.
From the Swedish Reindeer Herders
Beautiful.
Association claims that looking for reindeer tracks in the snow is the most reliable indicator of where the herds are going. Yeah, right? Take
Like
a
I go
look.
out in my backyard, I have
Right.
deer tracks all the time. I mean, I go out there and see, especially when it snowed this week,
Yeah.
and I had tons of tracks, all kinds of tracks.
Do you? Cool.
Yes, I always do. Yeah, tracks and
However,
go ahead.
However, this entails high quantities of fuel for many hours of driving and manual tracking. Other effective yet more expensive tracking options include the use of helicopters to locate the herds.
Mm.
Apart from being a big current crisis in the Lapland reindeer industry currently, the weather conditions caused by rapid climate change are likely to become a trend rather than a one time occurrence, as the Arctic is estimated to be warming twice as fast as any other region on Earth. And actually, it's more than that, but that's the conservative estimate, could
Mhm.
be up to 4 to 5 times as fast. The snowy conditions in the polar circle are more and more likely to be disrupted by warmer temperatures during the winters. Reindeer migration might become an annual routine, which will put Sami traditions, culture, and livelihood into serious strain and the reindeer business into jeopardy.
Wow, let's look at that again.
Yeah.
Oh, animal night.
Yeah.
Animal night. Well, let's see the next one. Oh, somebody just said major deer call going on this week just south of Montreal. Wonderful.
Oh,
Oh, brother. Well,
sad.
let's move on. Let's move on. This next one is it's a Florida outlet, and it
Mhm.
is called Wink. And I checked it out, and let me move us a little bit so we
What's
can see
what's
the
up?
article. It's
What's up
fine.
with Wink?
Wink is fine. I was really
Yeah.
actually happy that I found this because I thought it was interesting to that a Florida outlet was juxtapositioning the Arctic with Florida. So why don't we tag team this? And there is a video in it also. So Southwest Florida is about as different from the Arctic as possible, but the two are still connected. A new report shows melting Arctic ice and warmer temperatures, which can have a big effect in Southwest Florida. It's always strange to think that melting ice in the Arctic can have direct implications on Florida, said Joanne Mueller, an associate professor of climatology at the Water School at Florida Gulf Coast University. But Mueller knows what happens there impacts Southwest Florida. We
Wow.
are going to be the first to feel the effects of the melting that they're actually seeing in the Arctic right now. So, what scientists are seeing as mapped out in NOAA's 2021 Arctic Report Card is not comforting. The report card covers vital signs, and these are topics that get covered every single year. And they include things like surface air temperature, snow, vegetation, greenness, said Twyla Moon, deputy lead scientist at the National Snow and Ice Data Center. For example, the melting Greenland ice sheet. And that ice loss adds volume, adds water, everything you talk about, Jen, to the ocean and actually influences faraway shores more than it influences Greenland, Moon said. Now, that change could impact shores much further south. I wonder if Ron DeSantis has read this. When we think of blue sky flooding or having higher tidal events and experiencing really coastal erosion, or saltwater getting into formerly freshwater resources at the coast. These are connected to this Arctic change of losing land ice. When the Arctic is far from here, while the Arctic is far from here, the changes are a glimpse, just a glimpse of an issue beyond the top of the world. It doesn't really matter where the melting ice occurs in the world. It's going to affect us first. So I'm going to play this video that was with this and set that up. It should be fine. Here we go.
The news doesn't
Oh, of
wait.
course there's a commercial.
Breaking right now.
Oh my goodness.
Holding a press conference.
When it
Well,
breaks,
while there's a commercial, I just will say, I think, and I'm sorry for not cueing it properly, but I will say that it's good that people in Florida are learning about this stuff.
Changes happening in the
Okay.
Arctic could be a sign of what's to come here. The top of the world is seeing rapid ice melt and warmer air temperatures. Wake News environmental reporter Stephanie Byrne tells us how these discoveries could have implications for us.
You probably recall getting a report card back in school, but did you know the Arctic gets one too? Don't take it from me. Dr. Twyla Moon is on the editorial team.
The report card covers vital signs, and these are topics that get covered every single year, and they include things like surface air temperature, snow, vegetation greenness.
And think of this one as a group project. It's going to take more than one person to make the grade.
And so it doesn't really matter where the melting occurs in the world. It's going to affect us first.
As FGCU's Dr. Joanne Muller will tell you, Southwest Florida could see those effects through sea level rise and warmer water. Warmer water because without ice to reflect sunlight and radiation, the ocean ends up absorbing it instead.
So if you then put a really intense hurricane on top of that, that could have really disastrous effects here in Southwest Florida.
Despite the grim report,
And I think talking about it with each other, realizing that we have similar concerns, and then taking those concerns into action, making changes in maybe what's in the school cafeteria or the solar panels on your church, or talking with your representatives, no matter their party, to say, we really want action on this front.
scientists hope with better education, we can change the grade. Stephanie Byrne, Wink News. Now.
To check out the report for yourself, head to the story over on the Wink News app.
Well, I thought that was pretty good for Florida, so why don't you take over the rest of it, Jen?
Sure, absolutely. Southwest Florida could see the effects through sea level rise and warmer water because without ice to reflect sunlight and radiation, the ocean ends up absorbing it instead. If you then put a really intense hurricane on top of that, that could have really disastrous effects here in Southwest Florida, Mueller said. Despite the grim report, it's not too late. Now, what do we call that? A hopoloptimist? What do we say?
Apocalyptimist.
Apocalyptimist,
Yes.
right.
Apocalyptimist.
In Apocalyptimist, you have to say it's not too late in every single article. It's obligatory.
Yeah.
I think talking
Like
about it
Elliotson.
with each other, which we are doing here, realizing that we have similar concerns, and then taking those concerns into action, making changes, maybe what's in the school cafeteria or the solar panels on your church,
Oh,
or
what she
talking
said.
with your representatives, no matter their party, to say, we really want action on this front, Moon said. Scientists hope with better education we can change the grade. Well, it started out well, but then this whole last thing.
It's Florida,
is-
Jen.
Yeah, well, you know what?
No, I
at
mean,
least,
really.
okay, no, you're right. I mean, at least they're talking about it, because until recently, you couldn't even say the word climate change in any government document in both
No.
Florida and North Carolina. Wasn't that the case?
No, that was
Sandy?
when Donald Trump became president. That was definitely they took it out. They took it out of some of the stuff. So it was not cool. So
Yeah.
now it's back. Now it's back. now these people that work for these or departments in our government have to put all this stuff back in until some other whack job has a whim of wanting to, pretend it's not happening. Yeah, exactly.
Absolutely. But, it is, as you say, Sandy, it's huge progress that Florida even has an article like that going on. So it's progress of a certain sort, right?
It's progress, not the words we love, the progress word, but growth, progress. But I would imagine that this wink might be a little bit more of a progressive news source in Florida because it's from South Florida, and South Florida has Miami, and it's a more progressive area. But it's still something, and I'll take it. And I was happy to find it. I was happy to find it.
Good job in your sleuthing.
Right. So actually, we've got thank you everybody for being here, by the way. This is really awesome. We've got a really good audience, and I'm still playing around with a few things, but I have a video that I made that actually has to do with the next article, which has been something that's been discussed for quite a while. And we'll look at the article really quick, and then I'm going to play my video. We're going to take our little break. We're doing really good on time. And this article is from the United Nations, and it's completely about the rain in Greenland. And while we're not going to read the whole thing, we'll just show you, there's a couple of pictures, and it's, for the 25th year in a row, Greenland ice shrinks. The sheet shrinks. We're going to play this video. Let's take our break and let's watch this, and you'll recognize something from it.
Okay, what do we got here? This is like a headline article appearing in phys.org, and it came out a couple months back. Rain on Greenland ice sheet signals climate change risk. Well, nice of them to come to the party here. I did a video segment some time ago discussing, winter rain on Greenland. You may want to check out that video. So this is not exactly a new thing here. This has been going on for a while. I want to state that up front. Rain fell at the highest point on Greenland's ice sheet, possibly for the first time in an event Danish scientists on Monday said was most likely driven by climate change. The rain was observed for several hours on August 14 at a measuring post more than 3,000 meters up on the sheet, the U.S. Snow and Ice Data Center reported. Rain to fall, temperature must be above or just slightly below 0 degrees centigrade. Interesting, it says centigrade, not Celsius. Signaling the risk that rising temperatures pose to the world's second largest ice sheet after Antarctica. This is an extreme event as it may never have happened before, said Martin Stendal, a researcher at the Danish Meteorological Institute. Probable that this is a sign of global warming. Okay, let me pause here for a moment. Now, if they're talking about the highest point in Greenland's ice sheet, okay, that's possibly a first time. That's basically almost like in centrally located. The rains that have been observed before, the winter rains that have been observed before, have been maybe perhaps towards the outer edges of the ice sheet, not as far inland or as far up the ice sheet as some of these other events have taken place. But rain has fallen on the ice sheets in the past. Perhaps not in the central portion, central regions of the ice sheet, but it has happened. Temperatures have risen above freezing at the peak of the sheet only 9 times in the past 2,000 years. 3 of those events have been in the past 10 years. On the previous 2 occasions, in 2012 and 2019, there was no rain. We cannot prove whether it rained or not at the 6 occasions before. It's very unlikely, which makes the rainfall we observed even more remarkable, said Stendal. The rain comes after a summer in which northern Greenland has experienced record-setting temperatures of more than 20 degrees This heat wave has seen the rate of melting of the ice sheet accelerate further. Its retreat, which began several decades ago, began to speed up in 1990. With a surface area more than 3 times that of France, the ice sheet covering Greenland locks up enough water to raise global sea levels by up to 7 meters. The melting is causing concern among scientists as warming in the Arctic is faster than the global average. Yeah, 3 times faster. According to a European study published in January, the melting of the Greenland ice sheet is expected to contribute to the overall rise in sea levels by 10 to 18 centimeters by 2100, 60% faster than the previous estimate. 10 to 18 centimeters may not sound like much, that's basically 4 to 7 inches or so. But when you consider the surface area of the Earth, that is a significant amount. And it will cause problems for coastal cities. Of course, you got the rain coming down, the heat energy in the rain, because it is above freezing, even slightly so, is enough to melt that ice. And then as the ice melts and this water starts intruding into the ice, it will worm its way down and could start leading to fissures and cracks forming in the ice that will help split the ice, help it calve more so, increasing the rate of calving, increasing the rate that the sheet disappears.
Well, there you go. I hope Jim, well, I'm going to ask him to see it. I don't think he's seen it, but I took his voice and had my way with it.
You certainly did.
That was fun. Yeah, I will upload it. Lone Wanderer asked me to upload it as a separate video, and I will. Thank you for asking.
Standalone.
I will. Okay. So, wow, we've got 92 people in the house, and that's a really nice number. Thank you again, guys. Thank you. And we're going to move on. And don't forget, please, if you're new, like and subscribe. Okay. Like and subscribe. More to come. So, the next article, Jen, is the New Scientist article. We've used stuff from New Scientist before. It is you'll take this one. It's the greenhouse gas, methane, and a fire alarm moment. And I know that we are somewhat doing a little bit of what we did last week, but the news it keeps coming, so all these outlets keep coming. So we're really not repeating ourselves. We're just trying to bring it out. And then if somebody missed last week, they have this week, and it's a different, this is from the 7th. So take it away, Jen. Yeah.
And it's always from a slightly different point of view, and has different facts and different perspectives. So this one from the New Scientist: record levels of greenhouse gas methane are a fire alarm moment.
I don't even think I have a fire alarm. I have a gong. All right. It's close as I have to a fire alarm.
Average atmospheric concentrations of methane reached 1,900 parts per billion. This is global, not a global average, not specifically in the Arctic, where it's much higher. Last September, the highest in nearly 4 decades of records. Well, yeah, absolutely. It's continuing to go up with no indication that it's going to stop. It's just a matter of how fast. Up. Rising levels of the powerful greenhouse greenhouse gas methane reaching a new milestone should serve as a fire alarm moment, say
Look at
researchers.
that.
Wow. According to data compiled, it's probably from the beaver dams, right?
Well, this one is actually in Brazil. This is a
Oh,
picture
this
from
is in
Brazil.
Brazil. Oh my
Yep.
goodness.
Yep. And it says that's a major source of methane emissions as well. It's all over the
Oh,
world.
wow.
Mhm.
According to data compiled by the U.S. National Oceanographic and Atmospheric Administration, NOAA, average atmospheric concentrations of methane reached a record 1,900 parts per billion in September 2021, the highest in nearly 4 decades of records. The figure stood at 1,638 parts per billion in 1983, just for perspective. So it's gone up quite a bit. It is scary, said Ewan Nisbet at the Royal Holloway, University of London. He says the record shows the importance of more than 100 countries acting on their methane cutting pledge at the COP26 climate summit. The new high is unsurprising because methane levels have been climbing since 2007, thought to be driven primarily by changes in wetlands and agriculture in the tropics, and to a lesser degree by leaks from oil and gas production. Quote, the September data continues the exceptional trends that we've been seeing over the past few years, said Keith Shine at the University of Reading, UK. However, the rate at which concentrations are rising is concerning researchers, with 2020 marking the biggest annual jump since records began in 1983. So we haven't been really tracking
No.
it globally
Doesn't
that
it seems
for very
not that
long.
long. No, it doesn't seem that
Yeah.
long, does it? Wow.
Yeah.
Wow.
Methane levels jumped by a record amount in 2020. Average atmospheric methane concentration increase or decrease parts per billion per year. And this is the graphic that shows it began in 1983 in their measurements.
Look at that.
And they are right. Since 2007, it's been on a solid upward tick. And this is kind of a cool graph if you go in and read the article yourself. It's sort of a little bit interactive the way it behaves. So
Should
it's
play with
too
it a little?
early. Yeah,
Yeah.
go
Well,
for it, Sandy.
I'm looking
Whatever
at
you
it
wanna do.
and I'm just seeing the interactive nature of it. I just don't know if it's
Uh-huh.
all that much or more just for a
No.
little color.
It's just kind of like a feel-good interaction. Doesn't really
Yeah.
do much.
That's
Doesn't
what
give
I
you more
thought.
information. It
No,
just
it
kinda
doesn't.
goes bloop, bloop, bloop.
Yeah. Okay. All right.
It is too early to say yet whether 2021 will see a record annual increase, said Ed
Ed
Dlugokensky.
Lukensky. Ed
I
Lukensky.
should have
That's okay.
skipped the name. At the
Ed,
NOAA
if you're
Global
out there,
Monitoring Laboratory in Boulder, Colorado,
yay!
where we keep all
I
the
have to
ice
give you
cores.
Boulder. Yay! Jennifer lives in Boulder and she's here with us by the grace of Gaia.
However, based on flasks of air analyzed up to the end of September, he is expecting a large rise. No kidding. Two possible drivers are wet conditions in the tropics, which are common when, as now, the world is experiencing a weather pattern called La Nina,
La Nina.
and the heat of the Arctic. So it's basically due to the wet conditions in the tropics per the El Nina and heat in the Arctic. Those are the two drivers. Do these conditions play a role in the increase in 2021? Perhaps, but it's too soon to know. The recovery of pandemic hit economic activity could play a role too. I could imagine a case where oil and gas emissions increase because we were getting back to normal, said Alex Turner at the University of Washington in Seattle. while the 1900 parts per billion figure for September is provisional and will be revised, Nisbet says, it is certainly a fire alarm moment and a reminder we really need to act.
A fire alarm moment. I guess
A
that's one
fire
I'm
alarm
just, I
moment.
think I'm going to have to get a fire alarm sound effect because it seems to me like we're having a lot of fire alarm moments, doesn't it, Jennifer?
Yes. Well, yes, the whole show's pretty much a fire alarm moment. Kind of.
Unfortunately, and that's it's tough. It's a very tough. It's tough. But here today we are. We're keeping it together. The animal articles are tough to read, but here we are,
Mhm.
and we're with all of you. Yes.
Indeed.
So, what I think we should move on to the Guardian, the lightning article,
Oh,
because
yeah,
this is a good one, and I want to set it up because they are giving me you have read so many articles, and they're asking me for a
right.
donation, which is, I like the Guardian, but I'm sure they have some big donators. What do you think? I hope
I
so
think
because
you don't
they
have to
don't.
donate to the Guardian.
I
You
don't think so.
definitely don't have to.
Not right now. All right. So here we go. Jennifer, why don't you take it away?
All right, shall we tag team this one?
Tag team this one.
Okay. Drastic rise in high Arctic lightning has scientists worried. The region's air typically doesn't suit strikes, so they have become an important climate crisis indicator.
Mm, mm, mm.
Wow.
They're doing this to me again.
What?
Oh, forgot. I have to register. So you keep reading, and
I
I
keep
will.
reading.
Yeah, I'll do it with nobody looking because I didn't see that it happened. All right, go ahead.
Okay. The high Arctic saw a dramatic rise in lightning in 2021 in what could be one of the most spectacular manifestations of the climate crisis. In a region where sightings were once rare, the Earth's northernmost region saw 7,278 lightning strikes in 2021,
Wow.
nearly double as many as the previous 9 years combined. So,
Combined.
if that is not exponential, I don't know what is. That's crazy.
Yeah, you're
Arctic
right.
air typically lacks the convective heat required to create lightning. So, the latest findings published by the Finnish firm Vaisala Annual Lightning Report have scientists like Vaisala's meteorologist and lightning applications manager Chris Vagaski worried. Over the last 10 years, overall lightning counts north of the Arctic Circle have been fairly consistent. But at the highest latitude of the planet, north of 80 degrees, the increase has been drastic. Such a significant shift certainly causes you to raise your eyebrows. And here is a very interesting chart. So it shows like how exponential this is getting. So the anomaly, look at this thing. The red is the 80 degrees north, and then 85 degrees north, it calms down. But there's something going on in the atmosphere that when you get to that threshold of 80 degrees north, the lightning strikes are just taking off to the point where
Wow.
they never were before. And it just we have to bear in mind, Sandy, all that dry permafrost, all that peat that's drying out, thawing out, and drying out. It's all very flammable and very, very difficult to put out. So if there's getting to be a lot more lightning strikes up there,
Boom. That's what's going to happen.
boom,
Boom.
boom, boom. With temperatures rising in the Arctic at least 3 times the global average, you see this article's a little bit more honest about that, or they're just more informed. Tracking lightning in the region has become an important indicator of the climate crisis. 3 things are required to generate thunderstorms, moisture, instability, and lift. The disappearance of sea ice means more water is able to evaporate, adding moisture to the atmosphere. Higher temperatures and atmospheric instability create the perfect conditions for lightning. Monitoring how lightning trends change in the Arctic can therefore reveal a lot about how the atmosphere is changing in response to shifts in the climate. Quote, changes in the Arctic can mean changes in the weather at home, Vygotsky said. Quote, all weather is local, but what is happening at your house depends on how the atmosphere is behaving elsewhere throughout the world. Changes to the conditions in the Arctic could cause more extreme cold outbreaks, more heat waves, or extreme changes in precipitation to Europe. The devastating wildfires that raged across Europe and North America last summer were at least in part sparked by lightning. Typically, less than 15% of the wildfires in any given year are caused by lightning, but these fires burn more acreage than human-caused fires. Identifying the conditions favorable for lightning-triggered wildfires is crucial to react quickly to the strikes. Do you want to continue?
All right. So the risk of being hit by lightning in the Arctic is still low, but the increased probability of lightning could threaten communities that have not had to deal with frequent lightning in the past. People on the flat tundra or ocean are vulnerable to lightning strikes, and lightning puts electrical and other infrastructure at risk of damage. In the U.S., which saw the second highest number of lightning strikes in 2021 after Brazil, Vygotsky and his team, they tracked more than 190, million incidences?
Yes.
24 million. Whoa. More than observed in 2020. A 214 study forecast a 12% increase in the frequency of lightning strikes with every 1 degree Celsius increase in temperature. A changing climate may increase the potential for lightning-triggered wildfires, Vygotsky says. Scientists can't tie a lightning strike from one day to the changes in our climate, but monitoring trends of lightning in the Arctic is especially important and something that will need to be studied now in the future. So it's going to be a bit of a hairy ride for some of the people that live up there. It's going to be a very hairy ride, actually. Yeah.
You know what, Sandy? You know what occurs to me? There are a lot of things that happen as the temperature increases globally. For every degree centigrade that the temperature increases, there's 7% more humidity in the air, right? The air is 7% hotter. For every degree Celsius that the temperature increases, right? It is 12% more lightning. So it's moister. There's more lightning. It's a different world. It's a whole different world. It's a moist world with lightning, much more so.
Yeah. Well, it's a different world where we all live.
Yeah.
It's a different world where we all live. Jennifer, we are at 50 minutes, so we actually have some time. Yeah. And I am going to give you the decision. Do you want to do the severe weather Europe, or do we want to do a deep dive into Counterpunch and Robert Hunziker?
Well, I think that this Counterpunch article is fascinating. And I took a look at the severe weather EU. It's very, very long and a huge number of graphs and hard to get through.
Not in 10 minutes. Yeah.
Not in 10 minutes. Yeah. Counterpunch isn't 10 minutes either. It's long. But I think it's fascinating just because it's by Robert Hunziker. What do you think?
All right. I think we'll bring up the rear with Robert Hunziker. We will do that. I'll start it off, and then we'll tag team this one as well. I think that would be a good way to do it. And
That sounds good.
here we go. Let me get us back up in our little squares. Okay, so Robert Hunziker, great author. When to build seawalls. And it all does. It all ties in. I mean, it all ties in from what we started with. During the month of December 2021, 2 warnings of impending sea level rise were issued by the highly respected groups of climate scientists. These are professional scientists who do not deal in hyperbole. Rather, they are archetypal, conservative, serious-minded scientists who follow the facts. The most recent warning on December 30th is of deteriorating conditions at the Arctic and Greenland. The second warning is the threatening collapse in Antarctica of one of the largest glaciers in the world. As these events unfortunately coincide so close together, one at the top of the world, the other at the bottom, should coastal cities build seawalls? Should they? And Florida better pay attention. At the scale of time and material and costs to build seawalls is nearly overwhelming. In fact, it is overwhelming. The U.S. Army Corps of Engineers is already drafting plans for a gigantic seawall to protect New York and New Jersey harbor and tributaries from surges and flooding. It's a multi-year study that should be completed this year, which is 2022. The estimated cost is US $119 billion, built out over a period of 25 years for 6 miles of seawall. Wow, 6 miles of seawall. I definitely think that's got to have the sadness. 6 miles, that's it. Yet, already there is concern that it may prove inadequate, only defending against storm surges, not rising sea levels. So, New York City Comptroller Scott Stringer has suggested 520 miles of exposed shorelines as an alternative plan. Now, that source is the U.S. Army weighs up proposal for gigantic seawall to defend New York from future floods, which was in Science Alert. The Army Corps of Engineers also estimated $4.6 billion for a 1-mile wall for Miami-Dade. That's right, they did mention that, and $2 billion for an 8-mile seawall around Charleston. It's not known if these bids are only for storm surges or for sea level rise, but most likely it's the former. A study by the Center for Climate Integrity at the Institute for Governance and Sustainable Development in Washington concluded if seawalls were built in every coastal community, the national cost over the next couple of decades would be $400+ billion. And this would be designated for storm surge protection. According to Yale Environment 360, that's nearly the price of building 47,000 miles of the interstate highway system. Holy shit.
Jesus.
Wow. That took 4 decades and cost more than $500 billion in today's dollar. And that source is who's going to pay the huge cost of holding back rising seas. So Jason Box, who we've talked about, we've had him before, not as a guest, but we've talked about him. He's a professor in glaciology at the Geological Survey of Denmark and Greenland. He created a 7-minute video on December 30th entitled Recent Developments in Arctic Climate Observational Indicators. Now, I hadn't planned to play this, so it's either we play it or we go on and you guys play it.
I say we go on because it's already going to be long.
All right. Then you take it away, Jen.
His final statement in the video, we're talking about Jason Box, sums up the facts. Quote, at these levels of CO2, the world needs to prepare itself for abrupt sea level rise. And I'd like to say something about these walls in Florida. It can only be for storm surge. It can't possibly be for sea level rise because Florida is on this limestone. The whole state of Florida is on this limestone that is riddled like Swiss cheese, and there is no way to keep the sea level out of Florida, period. And that is
Period.
why we say Florida is toast. This can only mean nations and states need to start planning on either building continent-wide seawalls. Can you freaking imagine? Which will hit taxpayers right between the eyes, or prepare residents of coastal cities like Miami, you betcha baby, to move to higher ground. There are no alternatives. For decades now, it has become only too obvious that world governments are not going to seriously tackle CO2 emissions to slow down greenhouse gases from warming the planet, with a resulting onslaught of rising sea levels. Here's Jason Box's opening statement, quote, I am part of a team of about 20 scientists and authors where we look at all kinds of observational records of Arctic climate. We take in everything like rivers, temperatures, snow cover, and so I am going to quickly take you through our updated summary survey of these observational records. The Arctic is getting wetter. This is just what we were saying, guys.
Yep.
There is more rain and more lightning instead of snow. It is the largest trend in the Arctic, except for the lightning. I mean, the whole thing's falling
Yeah.
apart, right? The increasing rainfall trend. Yeah, it's raining in the Arctic like frequently, like in the middle of winter, like, you know, it rains at the North Pole in the middle of winter. That
Yeah.
should set off the alarm
That a
bell
kick in the
right
pants,
there.
huh? That
Yeah,
should
start
set off the
kicking the
environmental
pants.
coffee house toilet flush of the day, actually. That is the toilet flush of the day moment. Yep, there you go. We couldn't go a show without it. We got to flush that right away. All right.
Yeah, that's right. That's an incredibly disturbing statement. Isn't the Arctic supposed to be the brutal cold of the North that freezes over as endless solid ice and importantly serves as the planet's biggest reflector of incoming solar radiation? Answer, yes. That's true, but that was pre-global warming. Nowadays, the planet's copper tone, i.e., multi-year thick ice, is almost gone, exposing it to severe sunburn. Moreover, counterintuitively, most of the warming occurs in the cold season of October through May. It is the most dynamic season in the Arctic, and some of the biggest changes in the permafrost are happening in that cold season. Yes, but doesn't permafrost mean permanently frozen? In fact, Dr. Box claims that permafrost is changing in the middle of winter.
Wow.
Really. According to the study details, using new, more authoritative data sets, looking at the rate of warming in the Arctic since 1971, it is warming at the rate of 3.3 times the globe. But on a seasonal basis, it's warming at 4 times the global increase during the cold season of October through May. This is what we were talking about last week too, when we were looking at how quickly the Arctic is heating up and where, right? That's what we saw. Not only is it warming faster in the winter, but the studies also found a non-surprising coincidence of extreme wildfires when temperatures are extremely high. For example, only recently, biblical scale fires, never before witnessed, hit Siberia. At the time, SciTech Daily's headline stated, meteorologists shocked as heat and fire scorches Siberia. And that was June 23rd.
We read that,
2020.
Jennifer. That was
Oh
in
my
one of our
God, that's
shows.
right.
That was
That's
absolutely in one of our
right.
shows. Yep.
Yeah,
I
indeed.
remember now. We covered that back then. Holy
That's
crap.
right. We
Yep.
sure did. The crux of the matter links land ice surveys of Greenland and the overall Arctic, which are some of the largest sources of sea level rise, illustrated on a chart displayed in the video. So they'll have to
The
go
link
back
in.
and check that video out, demonstrating an increase in the sea level contribution every decade. Sea level rise. Oh, you want to take it?
Well, what I was going to say is perhaps I could play the video when we leave
Oh, okay. That sounds good.
as
Let's
the
do that.
closing video. Okay.
That's good.
So
That's
I'll
good.
take it for a bit. Sea level rise, which has been relatively quiescent throughout the Holocene era over the past 10,000 years, is starting to accelerate. This is extremely bad news, meaning the climate system is breaking away from the wonderfully stable Holocene era of the remarkable forgiving Goldilocks climate. Not too hot, not too cold, but now all of a sudden it's no longer remarkably forgiving. As a result of so many years of the wondrous Holocene era, humanity got spoiled rotten with very stable sea levels and, as a result, far too complacent. But complacency gives rise to repercussions. According to Jason Box, future sea level rise contributions from land ice, and especially ice sheets, is very difficult to project into the future. However, here's what sends a shiver down the spine, he went on to say. At best, we can say at those levels of CO2, the world needs to prepare itself for abrupt sea level rise. At best, prepare for abrupt sea level rise? Oh my gosh. Do you think that that's going to happen?
Oh,
There is no
definitely.
subtlety about abrupt. It means sudden and unexpected. Now, this brings on climate change warning number 2, Antarctica, the Thwaites Doomsday Glacier in West Antarctica. Satellite images shown at a recent meeting on December 13th of the American Geophysical Union show numerous large diagonal cracks extending across the Thwaites floating ice wedge. The ice sheet glacier, it could collapse, and it's big. 80 miles across with up to 4,000 feet depth and with a 28-mile wide cracking ice shelf that extends over the Amundsen Sea.
Oh my God. So
Go
big.
for it. We're going back and forth with this one.
New Scientist article on December 13th, 2021 discussed the satellite images of Thwaites' massive cracks. Quote, Antarctica's Thwaites Glacier could break free of the continent within 10 years, which could lead to catastrophic sea level rise and potentially set off a domino effect in surrounding ice. Meanwhile, by year end, both poles, north and south, are rumbling and threatening coastal life throughout the world. But frankly, nobody knows how soon or how high the seas will react. 1 to 3 feet this century, 1 to 3 feet within a couple decades or more, in less time, maybe 10 feet. Or how about several meters? This said, nobody knows.
Nobody knows.
Nobody knows, which is a calculation used in a study in 2015 by James Hansen of Columbia University before scientists knew what they know today. And that was only 6 years ago. 7 years ago.
Yeah.
Dr. Hansen's paper was published in the Atmospheric Chemistry and Physics, Ice Melt, Sea Level Rise, and Superstorms, Evidence from the Paleoclimate Data, Climate Modeling, and Modern Observations that 2 degrees global warming could be dangerous. I remember when this article came out,
Yeah.
and it
me
is
too.
the most fascinating thing. And he found these giant boulders of out of place things that are like coral, it's just wild. That's a There were a lot of authors on that paper. It's a very good paper. Look it up, read it if you're
Maybe I'll try to
interested.
put the link in to make it easy.
Yeah. Yeah. Part of the Hansen argument is paleoclimate evidence during the Eocene period 120,000 years ago, when the Earth's oceans were 6 to 9 meters higher. That's 20 to 30 feet, at less than 1 C warmer than it is today. So that's what we're looking at. We haven't even caught up to what it should be, because the carbon dioxide and the greenhouse gases have gone up so quickly. They haven't reached their full heating potential, and it has to reach its full heating potential before the ice melts according to that. So sea level rise is exponential, and there's no turning back. It's exponential until it's not, and when it's not is when there's no more ice. 6 years after Dr. James Hansen's warning, scientists who study the Arctic and Antarctica are echoing his words, but with more immediacy and concern. So it was 6 years ago, and it took the world 6 years to catch up to Dr. James Hansen.
We don't have the time.
I know. In plain English, Jason Box did say, at these levels of CO2, the world needs to prepare itself for abrupt sea level rise. You bet. After all, who has a better grasp of the situation than Dr. Jason Box, professor of glaciology at the Geologic Survey of Denmark and Greenland? But did you know that Jason Box is from Colorado? I bet you didn't know that.
No, I did not. And I think
Yes.
Paul Beckwith interviewed him. I think it's Jason
Did he?
Box who he interviewed at COP. I think, if my memory serves me, if anybody remembers the chat, in the chat, if you remember, I think it was this year. I do. I think it was.
Really?
But
Okay.
yeah.
Well,
All right.
all right.
Warnings. Warnings today are more pronounced than ever before, even though the biosphere is not yet at 1.5 C above pre-industrial, widely considered the IPCC safe limit, or is it? Now, that depends upon how pre-industrial is calculated, and this is what we were talking about with Elliot. Elliot was talking about this in our Friday night discussion. Exactly. And there's always controversy over this. Always. Is it 1750 or 1880 or 1950? But even if we're not there yet, the damage caused to critical ecosystems at only 1.2 C above pre-industrial, where we are today, is enough to write a book. A very long book. Nevertheless, what is known today is that preparations and build-outs of seawalls will be decades in the making and dreadfully costly. Is there an alternative? I mean, once sea level makes its mark higher and higher, it's too late to start drawing sketches and drafting plans.
Well,
yeah,
you bet.
because you know what that is? That's magical thinking. Yeah. Okay. So climate scientists who are on the front lines of climate change are sending smoke signals of a looming threat on the horizon. It's much closer than anybody expected. Alas, considering the disquieting fact that climate change in real time has been outpacing the climate models of scientists by quite a wide margin for quite a long time, abrupt sea level rise needs to be respected as a distinct reality. So an article by M. Farquharson et al. In Geophysical Research Letters dated June 10th, 2019, observed maximum thaw depths at our sites are already exceeding those projected to occur by 2090, which in other words, oops, that's a big one. Oops. In other words, field work in the high Arctic found cataclysmic impact of climate change happening 70 years ahead of what the scientific models expected. Now, models, that's always something. I'm going to look for that video. I have the video, but let's do a little postmortem on this one,
You
Jen.
forgot the last two words.
Oh, I did? Oh my God.
Yeah.
Oh yeah, the last two words. Here they are. Do something. Do something. Do
Right.
something. What do you think?
Well, at least become aware and understand what the heck is going on your
Yeah,
beautiful
watch
earth.
Environmental Coffee House.
Yeah. And then, given all the knowledge that you get, figure out something that's good to spend your time on and do.
Well, yes. And Robert Hunziker is a really good writer. I mean, he's prolific.
Really
He
good.
just writes it. He gets you right where it is. I've read his stuff before. We've read his stuff before. Collapse Chronicles has read his stuff before. Who hasn't? He's one of Counterpunch's really good writers. Well, I can show this video. It's a 6-minute and 57 video to finish, and
Okay.
I think you're all here to. You know what? I think we're going to play it.
Okay, cool.
And then you know what, Jen? Why don't we come back and just say goodbye
Okay,
right after
yeah.
it's done?
We'll come
How's
back,
that?
say goodbye, and
Yeah.
put the normal footer on.
All right. Don't leave. Yeah, here the normal footer. You mean this? My little thing about becoming a member of Biosphere Coffee. Please don't forget. Yeah.
The video, the normal
I
goodbye
know.
video.
Oh, you mean I didn't get to do my my little thing here? All right, here we go. Let's get this going. Come on, play.
Thanks, everyone, for being here. I'm part of a team of about 20 authors where we look at all kinds of observational records of Arctic climate. We take in everything like rivers, temperatures, snow cover. And so I'm going to quickly take you through our updated summary survey of these observational records. How is the Arctic climate changing according to observations? The Arctic is getting wetter. Precipitation rates are increasing. Snowfall is part of the precipitation. It's, as you can see in the brown areas, actually decreasing across the North Atlantic. Why? Because there's more rain falling instead of snow. The largest trend in Arctic precipitation is the increasing rainfall trend. So the overall precipitation increasing, driven by more rain at the expense of snow on average. There are some hot spots where snow cover is increasing, like along Greenland, Svalbard. But again, the overall pattern looks like this. It's a wetter Arctic. The temperature increase annually, as you can see, is largest in the Barents Sea sector. This is where the Gulf Stream circulation kind of ends. This is the
Hang on. I don't know what happened.
margin of the sea ice. It's a very dynamic part of the Arctic, and it's warming the most at the annual scale. If we look at what I call the warm season, that's June through September, it's warming at a lesser rate, partly because extra energy goes into converting ice into water. That's a latent heat sink. It's the cold season, October through May, where the most warming is. And that is a time of year where it's actually, in some ways, a much more dynamic system. Stronger storms, stronger atmospheric circulation, and some of the largest permafrost changes are happening in this cold season because it's warming up so much at that time of the year. We had a close look at how quickly is the Arctic warming compared to the globe, and using new, even more authoritative data sets, we find that at the annual scale, the Arctic since 1971 is warming at 3.3 times the globe. Seasonally, it's 4 times the global increase in the cold season, October through May, and about 2 in the warm season. So again, this cold season, October through May, is when most of the change is occurring. Wildfire. There's a non-surprising coincidence of extreme wildfire when temperatures are extremely high. Just a record from Alaska, and here's a record from Finland showing the same thing. It's not every year. Temperature alone is not the only predictor of wildfire, but the extreme high warm summers are when the most fires occur. The tundra is getting greener. It's predictable by the temperature increase and the wetter conditions on average. It doesn't mean that the Arctic is wet in the summer. It can be very dry, but overall, it's a wetter Arctic, and it's also a shrubifying Arctic. More woody stems growing up taller. The willows are getting quite big in the Arctic. The northern limit here, this is what you see in this map, is north of tree line. So this is all the Arctic tundra that's greening, but it is greening to the south of tree line as well. Arctic sea ice declining by more than 45% in the period of high quality satellite observations. And the sea ice volume decreasing by half. We've lost half of the sea ice volume in the last 43 years. The Arctic rivers are discharging more. They're flowing 8% more than they were 45 years ago. It's also significant because this Arctic Ocean basin, it's 1% of the global ocean by volume. So it's not a very deep ocean, but with these great rivers discharging into the Arctic Ocean, it's 10% of global river flows going into a volume that's only 1% of the global ocean. So these freshwater dynamics are really transformative for the oceanography of the Arctic Ocean. And finally, our survey includes land ice. That's the glaciers, ice caps, the Greenland ice sheet. The Arctic is the largest single source of sea level rise globally. And in each of these decades that's illustrated by the gray lines, in every decade going forward, there's an increase in the rate of sea level contribution. In other words, an acceleration. And that makes the future sea level contribution from land ice sheets especially very difficult to project into the future. Ice sheet modeling is a very tricky business. And so at best, we can say at these levels of CO2, the world needs to prepare itself for abrupt sea level rise. Thanks for your attention. Look forward to the discussion.
Wow. Sandy,
Okay, I'm not
going
to play the whole thing. I'm not going to play the whole discussion that he talked about. I thought it was really good. I just want to say thank you to our moderators, Jennifer, Kameshwari Kate, and Matt Hunter. Wait. Sorry. Matt Hunter and Kim Centeno. Thank you, guys. And Jen, why don't you give the parting shot, as always?
Well, there's so many things happening, and there's so much news coming out, and it's all connected. Today we talked about lots of different animals. We talked about the Arctic melting. We talked about Antarctica melting. We talked about sea level rise. We talked about Florida. And it's all related. It's all the same body of knowledge, just different facets of it.
Yeah. There you have it. There you have it. Thank you, everyone. And I really do appreciate all of you. Jennifer, until next week, we will let you know if it's Friday or Sunday. And thank you. Thank you. Thank you. We really
Thank
love
you
you
all.
guys, all of you. Thank you again. Good night.
Night, night.